Hello everyone again. So this is a recent update on my custom mess here, hands-free little project. I just made a slight update to the code and programmed it. This is just the serial to TTL adapter. If you notice, the jumper here has not been set neither to 3.3 nor to 5 volts. It's in the middle. You can remove it completely because the power is being, and the ground of course, is being sourced from the car. So please don't keep the jumper on when you're doing these programmings. If the Arduino is not connected to the car, you can, of course, you have to actually supply power from the UART. But if you are connected to the car, and of course if you see, this is the plus and minus power supply coming from behind the radio. This is the CAN bus signals from the CAN to the MCP, and this is a little Arduino here. It's covered by tape now. So if this is connected to the car, do not power from USB. Okay, keep it separate. You don't need it. Just unplug the jumper, or if you don't want to lose it, just keep it in the center here. This is 3.3, this is 5 volts, as you can see, but it's in the middle. That's an important thing. Maybe I forgot to mention it. It's important to keep it like this. Here in the serial monitor, you can see I filtered some commands out. This is volume plus, volume minus. Press play if you want. Let's say phone button here to play and record. You can hear the music now. If you keep it pressed, you see it won't stop until I release it. This is the fix, let's say, that I did, so that if you press, you don't need to press it quickly. It won't call the last dial number. This is the little patch. At the moment, if you double press it, it won't call the last dial number. I disabled that feature because to be honest, it's more a pain for me, so I just removed it. If you double click, you see it just plays. You see? Press again, it will stop. If you keep pressed and release, it will only play and stop. You see? Look how quickly the command is processed. You see, like 4 times the button is pressed. It samples it about 10 times a second, something like that. This way you won't inadvertently call the last dial number if you want to just start, just start. There. So that's more or less the code update. I will upload this as soon as I can. For the rest, everything is as before, so you just need to update the code if you haven't. Let me stop this. Okay. You just need to upload the code. If you haven't already installed it, just use the latest code and you won't have any problems. The next and previous, as I already mentioned, this is already fixed, meaning that you can adjust the Bluetooth volume with it. Just keep pressed. So if you start the song, if you briefly press it, it will go to the next. Here, you can check. Previous, next. Okay, but if you want to adjust the volume and you keep it pressed, volume is going down, volume is going up, you see? And this works fine. It's already, this was the base, let's say the base code. For the rest, it's, as I said, all you need to do is set up this little... Yeah, that's me. I press the button on the back. This is the little USB board and the buttons are on the back. So if you mess around with it and press, sometimes there's a Chinese voice coming out. That's not been updated. I mean, that's based on the board. The numbers are okay. It speaks in English, so when somebody calls you, it will announce the numbers. That's the firmware on this red board. It's the Bluetooth board that actually does everything. The Arduino just interprets the CAN signals from the BMW CAN and simply just presses the buttons on the board to start and stop. There. As you can see, cyclically you get this C00C. That's normal. It does this once per second. It's a routine loop check, and it checks the KCAN for activity, and then it's just normal. So you should see this. There are a lot of commands, running through the bus, but I programmed the MCP, which is this little blue board here. I programmed the MCP to filter. It's explained in the code. There is a filter to just filter the commands going to the radio. That's all we're interested in. Otherwise, there would be so much data here that the Arduino wouldn't really be able to process it, because it's really kilobytes of data and it's way too much. We just are interested in these commands here. As I said, this also works. If you press it, you get now it's on AUX. Now it's back on radio. If you have a USB or micro SD card plugged in, you would hear music from there if you cycle it from here. I just don't use it. It's nothing. I don't really care. But you could, as I said, pop in an extension USB cord, and you can plug in stuff here. So if you have a USB with some MP3s on it, you could use that too, without using the phone or the aux port on the radio. Another thing that I'd like to underline is that you see my car has an AUX input. So this model, which is a Futura, already came with the AUX enabled. Some cars do not have this option. You can enable it, okay? You do not have this, but you can enable it. And to enable it, you need to do some coding through the INPA or whatever, NCS Expert or whatever tools you have, to enable that bit, so that the radio will enable the AUX input. You don't have the wires, it doesn't matter. Those 3 pins which I showed in the previous video and described, they will be used for the output here. As I see, I used a plug, a jack, because it was very handy. Just cut a jack to jack extension and just solder it on the back here. I already showed that in the last video. And then there is a second jack here to have a bypass. What you could do, if you want to do like a more, say, cleaner job, you could wire, if you have the AUX model like I do, these 3 wires lead to the back of the radio. You should remove them from the back of the radio, plug them in the input here, and then from the output route this to the AUX input. This way, the impedance wise, it's much better. But if you don't do it, it's not a big deal. You see, I never use this, so just do not leave anything plugged in here, so that it won't change the impedance input of this jack. If you do, well, I mean, I tried, it works. The volume will be slightly lower. I never use this, so I just I just left it like in parallel. I just wanted to clear this so that people wouldn't, many people have like some Bluetooth thing stuck here. Well, you wouldn't be using that if you have this, of course, because I would defeat the whole purpose of it. But if you have like a phone and you want to plug it in, and you have this plugged in, keep in mind that part of that signal will be loaded by the input stage here, so the volume might be lower, and it's not, nothing will break, of course, because we're talking about really microcurrents here, but there is a different impedance here. So if you want to do it properly, you take the input that's going to the AUX, wire it in a jack, plug it in the input here, and then take the output and wire it back to the radio. That way, if you select input output here, you can toggle through this and as I said, you would hear it properly. You should hear actually a voice. Let me just turn the engine on. Okay. When I'm cycling through here. Where is that? Oh, here. Voice button, you see? These are the two inputs or something like that. So let's see. This. Okay. Yeah. I'm trying to like press the buttons, and see, it's supposed to be playing. Then you cycle through this. CD radio AUX. Play. Radio. And yeah. There's something on the equalizer. Okay, well. You see the it's flashing, and now it's connected because I was on the AUX mode, and that disables the Bluetooth. And now you see the blue, I don't know if you can see it, the blue LED here is steady, meaning that it's connected, and you heard the little bing, so that tells you that the Bluetooth is connected. So now if I press again the play button, you should see the play button here, execute play, and the music on my phone starts. As you can see, it's blinking slowly, which means it's playing. So these are a little bit status updates on this little module. This is all this red module here that you see on the bottom. Yeah, I'm sorry it's a little bit all messed up because it's taped up, but there are pictures showing it more clearly on the various websites, so you should, get the hang of it. As I said, these colored wires, I colored them so that you could see better how to solder them on the other side. There are pictures. Please solder them the correct way around, because some are soldered on the left of the switch, some are soldered on the right. On the other hand, here there are push buttons, and that's because to explain it, this board responds to not different inputs but different levels of input. It has one input to its own microprocessor on board, and there is an array of resistors. So when you press the button, based on where the button is, you get a different voltage divider, okay? And that is detected by the microcontroller, which has an analog to digital converter, and based on the voltage that you are generating while pressing that specific button, it knows what command you gave it. So it's important that you wire them in the correct sequence, but also that you keep the pull-ups disabled, because, well, if you use the code and just program it as I sent it, it's fine. Everything works. And it's just to explain a little bit how the board works, because I didn't analyze the board in the beginning, and to me it looked like it had separate inputs, but then it wasn't really working correctly. And then I found out that if you look at the push buttons, every push button has a little resistor which goes to ground, and when you press it, it will generate a different voltage, and the input is actually one line. So that's basically some background on how this little board works. Maybe others work differently, but okay. If you get this board with a list that I showed, this is how it should be wired. Pictures are on the site. Colors make it a little bit more simpler. Some other questions were related to the power. Okay, as I said, momentarily I connected it to the +5 bus, and this on these cars is stays enabled. For example, if I turn off the engine, it stays enabled even after I turn off the radio. If I push the radio off, as you can see, you see it's still flashing. This is still powered because the pilot just turns off, but the radio and the +5 from the bus, it's still on. So that turns off basically after about half an hour. Actually, it's half an hour precise, I think, on BMW. If you don't want this, you have to use a little transistor. There are a lot of let's say simple schematics. Collector, base, and emitter. Use I think a 10K resistor is fine on the base, and collector, emitter. Then you connect it to the input here, so that when the base is powered, power flows through the collector to the emitter, which is connected to the plus input here. As I said, this is not so difficult. You can find a lot of schematics to do this. If you don't mind that, you know, powering this thing half an hour after you've turned off the car, the only drawback is simply that when you turn off the radio, your phone's Bluetooth will be still connected to this receiver. So if you receive a call and you reply and you're in like 10 meters of your car, you won't hear anything because your Bluetooth is turned on and it's going nowhere. So you're gonna have to turn the Bluetooth off from your phone. Just, you know, it's pretty simple. But if you just park your car and you leave, it's not a problem. This will not draw any significant amount of current. It's like 20 milliamps, maybe even less. I think it was around 12. So it's really ridiculous. It's not a problem. Additionally, I also added, in my case, a resistor to drop even more the 12 volts, more closer to the 6.5 volts, so that the onboard regulator of the Arduino here, this board, will be less stressed. The lower the voltage drop, the less heat dissipation occurs on the regulator. As I said, it's not really important, but okay, you can do that with a tester. I don't remember the value I added here. It was some ohms, I don't know, maybe 100 ohms, I don't remember. It wasn't a lot, 50 ohms, something like that, because this thing absorbs really. It's about, when it's all on, without the, of course, the USB to serial, I think it's around 55 milliamps without any USB plugged in, something like that, maybe even less. I think it's 36 to 39. So, you know, it's very, very low current. The onboard regulator on these boards, on the Arduino board, handles 100 milliamps by design, so it's really not a big deal. Again, as I said, if you want to properly turn it off, you will have to add this little circuit. Well, that's just one transistor to the output from the plus, and I would always suggest adding a fuse, 250 milliamp fuse, normal, slow blowing, whatever, in series is always a good idea, because you never know if you short something out here, because the plus bus here has I think it's a 30 amp fuse in the back of the compartment here, and it's actually kind of like a pain to swap, but okay. So be careful when you're soldering the plus 12 volts on the back of the radio here. You're picking back on the connector, because it's powered if you are in the car, for sure. So, you know, keep that in mind when you're soldering the plus. The pilot output, if the radio is off or the quad lock connector is unplugged, it's not a problem. You can bring the wires down here with a fuse on the back, and then put the little transistor here and power it if you want. Other things, basically that's it. This was just the last thing that was bugging me, because, you know, if you keep this pressed, you would have to really be fast, otherwise it would call the last number. I honestly don't use that feature. If I need to call somebody, I usually just look up the number and just call it. And if you receive a call when the music is playing, you will hear the voice saying you're receiving the call from the Bluetooth module, and you just simply press the button to receive, to accept the call. That's all. That's it. As you can see, cyclic COOC every second, basically. That's it. So okay, I hope this was explicative enough. My microphone is here. I didn't wire it all the way around up here. It's originally it's supposed to be in this area. You have to wire around a wire around the window, go down there, remove these profiles here, these fittings, and then just put the wire around inside and here. But to be honest, it works fine here, so my choice was to leave it here. It's kind of like, you know, as you can see, I have a lot of wire to do that, but I just left it here. It's fine, picks it up pretty well. Yeah, those trimmings are not a problem to remove, but as I said, you're gonna have to, if you want to hide it well under, you usually go around here inside and come in from the back there and then up here. But okay, there's a lot of space, so basically that's it. Okay, well, I hope that does it. So by the way, Merry Christmas to everyone and a Happy New Year.